Hey Joe, here's the little demonstration video that you asked for. I have the camera set up like it was for the demonstration in class. I can arm, and it goes into the tracking mode. Let me switch the camera around. So it's doing the tracking, and it's currently looking for faces. So the way this works is it sends the control board G code, right? So it goes, X0, X10, X20, X30, X40, so on and so forth, right? And that's just a list of predetermined values to check in. And if it detects a face, right, so in between every move, it looks for new
There's so much
faces,
elegance in that look. Let's highlight every detail.
and it takes a picture just like that, right? As well as running the text-to-speech. And it also goes into the tracking mode, so if I were to stand in front of it when it did that,
You look like a dream tonight. Give
Alright,
us a
so
gentle
it's
smile
found
to
me.
seal the moment.
and now if I move a little bit,
Your presence is
It'll
magnetic
try to
tonight. The
track
carpet
my
has never looked
position.
better. You're glowing tonight.
I
You
have
need the
an
world to see
issue
it.
with this feature where when
All
it's
that post
running
the
the
world
text
needs
to
to see
speech,
this
it's
fashion moment.
blocking, so it blocks the webcam.
Confidence looks
and
incredible on you. Don't hold back.
The
Just one more shot. Your
face
fans are going to
position
frame this one.
doesn't update until the very end of the picture taking process, right? Because the face detection and the capture code is blocked. So the face
Over here
position
to your
is
left.
old
Give us
by
that
the
dazzling
time
smile
it,
everyone loves.
actually moves to that position. So that's the issue I've run into with it. That given some more time, I'd like to resolve, but I'm out of time, and I think that involved multi-threading, which isn't something I've really messed with before. Alright, let's look at the code a little bit. Okay, well before we look at the code, the way it actually works, the way I get the image off the camera, is I'm running the software called Digicam Control. And this part's a little hacky, but it was
Work
the
that dress
easiest way
like it
to
was made
achieve
just
what
for
I
this red
wanted.
carpet. Flawless.
So what it does is Digicam Control is what I use to control the camera. So it displays a live feed on the display, and it allows me to trigger the camera using a keyboard shortcut, which my program emulates. So I have Digicam Control running, and then OBS captures the display, and then emulates a webcam, which my program latches onto and uses for tracking and face detection. So let's look into that a little bit. Okay, so I'll probably go back and change this by the time I turn in the code, but right now most of the logic is in UI. So, and I also have some other modules that I import. So, all this stuff here, this is like standard tkinter stuff just to set up the buttons. Arm, disarm buttons, whatnot. And then down here, this this run track, this is the real meat and potatoes of the program. So what it does is it grabs an image from the camera, and then it runs it through my face detection algorithm to detect a face and get the relative angle between the camera and the face. And this code here, so what this does is it offsets the value, the Y value, by 15 degrees in order to achieve proper framing, right? Because otherwise, it'd try to point the camera directly at your face, right, with your face centered in frame, but that wouldn't really make a very good shot. So I offset that value by 15 degrees to approximate like kind of the rule of thirds sort of thing. All right. So if Rx is not none, really this could be Rx or not, or Ry, because this here will return none if there's no face detected. So if there is a face detected, okay, well it'll move the camera towards your face, right? And these divided by 2s, these here are kind of magic numbers just to make the tracking work best. That was something I had to tune a little bit. Probably, maybe in the future it'd be better if these were exposed somewhere as something I can change. Alright, so it goes through one tracking cycle, right? It tries to point at your face, and it checks, okay, am I framed well enough? Am I within 15 degrees of where I want to be? And if it is, it takes the picture, right? And then Canon.scan, so if none of these things are satisfied, right? So if there's no face visible, it will scan its surroundings until it finds a face. And in between, and the robot needs time to move, right? So it starts at 0, and then it moves to 10, right? And this here just adds a little more delay for it to get to that set point before it tries moving again. Issue I ran into without that code was that the controller buffers the G-code commands, and they all kind of happen at once, and that was a bit of an issue, but this resolved that, right? Because what would happen is all my individual moves would get squished into a single move. Sorry, I had to answer the door. Alright, so let's see, where were we? Oh yeah, so that fixed the buffering issue. And then this window after here, this is kind of how you run a loop in tkinter without it being blocking, right? This says, after 750 milliseconds, call itself, right? So run track. So this whole thing runs every 750 milliseconds. Okay, and then take picture. This code's pretty simple. It says a line. I'll show you this say a line code. So it says a voice line, and it presses the space key, and then let's go, and that takes a picture. Let's see. Oh, and then this here is creating my text-to-speech object, and then in the say a line code, it picks a random phrase out of my list of red carpet lines. It's a pretty long list, and it says it, and then this engine.run and await waits for the line to finish saying before it continues on. That blocks the code. I tried doing it without that, hoping it'd fix some of my kind of slowness issues, but I didn't have any luck with that, unfortunately. It seems like it needs that code to work at all, or else it threw errors. Alright, and then def cam. So this here is the code that grabs the frame from the camera, and it draws the rectangle over the faces, right? All faces visible in frame, and it let's see, frame face center. Yeah, and it draws the circle on the kind of averaged position of the face. So whichever face is most dominant and consistent in this scene, it will try to recognize and put the circle on it. And then on closing, this is just like some housekeeping stuff. Alright, so let's look at face detector. I'm pretty proud of that part. So face detector is pretty neat with how it works. It just uses the built-in CV2 face detection algorithm, but there's some cool stuff that I added on top of it. So I created this rolling average class, which is just, as it sounds, a rolling average. You pop values in. It's a set length of 20 values. Every time you pop a new value in, it throws out the old value at the end of the list. But it has a cool feature where I can put in none values, right? And the usefulness of this is that it allows me to add values, but if there's no face detected, to put in nones in its place. And when it comes to grab the average position from that list, what it will do is it'll go, okay, are there at least 8 valid items in here? If so, well, I can somewhat assume that there's a pretty consistent face on screen, and I'll deliver that to the other code. So, and I'll show you that down here. So face detector, I create my rolling average for X and Y. All the CV2 stuff. I turn it to grayscale. I look for faces. Get sorted list face size. So this sorts the list of faces in order of biggest to smallest, and it always assumes that the biggest face on scene is the one that you want. So if there's multiple people in a group, whoever is closest or whoever has a apparently larger face, that'll be at the beginning of the list, and it'll pick from that one when it goes to average their positions. Face center, it just does the center of a line formula. And then get average face position. So this goes pretty cool. It does pretty much what I said. Something in addition to what I said it does is it gets the it checks, okay, I have this average of face positions. Is this new face position an outlier? And if it is, it throws it out and it just adds a none to the list, right? Because that is likely a false trigger. Usually false triggers get detected less consistently than real triggers, so it's a somewhat reliable way of excluding those false triggers from my average. And then get relative angle attempts to get the relative angle of the face to the camera, right? So theta. Yeah. And then here I just have some testing code when I was figuring it out. Utils, it's just linear distance, pretty simple. Let's see, red carpet, these are all the red carpet lines. And then canon.py, this is some repurposed code from my the school is out canon, like where it, I forgot what I called it, but where it scraped the my mother load list of school delays, and if there's a school delay, it'd go off. This is some of the repurposed code from that, just because it did the serial communications, and I didn't want to re-implement that. I threw out pretty much all the old stuff. If I were to do it again, I'd probably rename it from Canon to Robot. Perhaps I'll do that in the code I turn in. That's a change I'd like to make. I think I'll do that. Let's see. So in here we have a couple methods. We have the absolute move method, which does what it sounds like. It moves it to an absolute position, right? So, 0, 35, those will always be in the same place. It moves to there. Relative move, it moves relatively, pretty self-explanatory. Scan, this is the scanning code that I talked about, where it has a set of predetermined places that it checks, and if there's a phase, it starts tracking. Detects. What does this do? Oh yeah, that detects for its serial devices. So all this is just the serial device stuff, and the arm and disarm button. Those are pretty good for safety and ensuring that the bot doesn't go rogue on me and tear all its wires out. So some interesting things that I learned from this process was that when you're doing anything with hardware, the bar for working is something that you kind of have to set for yourself, because it seems like in software, for the most part, things just kind of work how you expect it to, and it's easier to have like a clear goal in mind. But what I found in this is that I have to have kind of like a level of like, I'm okay with this, like this works well enough. So that was interesting to experience. Hey Joe, just one more thing I wanted to add on. I forgot to talk about how the computer actually speaks to the robot. So since I'm using a standard CNC control board and CNC control firmware, it's pretty commonplace for those devices to have the ability to have G-code streamed to them, and that is usually done through RS-232 serial, which on a softer level is being emulated by the drivers. So G-code's pretty simple. I can give commands like G0, which is a rapid move. So that says, okay, go from this point to this point as fast as possible, pretty much. And then I can say, okay, go to X20, Y0. And it goes there. And this is all in absolute positioning, right? So it has an origin, which is the point at which you turn it on, unless it's set otherwise. And then when you send these commands, it moves to its respective location. So I can send, G0, X0, Y0, and it goes back there. And then the same thing, I can also go like move both at once, and both move. So pretty simple concept. It's pretty neat. I did have some difficulty getting this to work because it's a little up in the air how some of the nuances function. And it's pretty funny because G-code has a pretty long storied history. It's existed for I don't really know how long, probably since like the late 70s. And it seems like every flavor of machine has their own flavor of G-code, so there's slight nuances between them. And something that was really tripping me up is that it expects a special line ending for when you send the commands, right? Because you can just send like a stream of bytes over serial, but it needs to have a line ending at the end of it, so it knows where the difference is. But different protocols and different standards and different machines expect different line endings. And I had trouble figuring out exactly which one I needed to use. So if I go to canon.py, I have my move commands. You can see it sends the same simple string, G0, rapid move, X to whatever position, Y to whatever position. And then I had to just use a /n. I tried a whole assortment of different things that didn't work, and I eventually landed on this one. So that was a bit of a sticking point. But it's really quite neat how simple it was to implement this portion of it. I feel like it has a lot of possibilities and possible use cases. For the actual mechanical design of the robot, this is something new for me. I've never really designed anything with gears or anything of that nature. But it was a fun learning experience, and there are a couple things I didn't get right on the first go. Funny enough, it wasn't the gears. The gears worked perfectly, but I mismeasured the motor mounts, so I had to drill new holes and to get those to fit, and they are kind of wiggly on there, but I don't know if you can see that. Yeah, but it works. It uses these large bearings that I found at the hardware store. I really would have liked to use ring bearings, but those aren't available locally. So that was my best approximation of that. This is kind of like a pretty standard gimbal setup. We have let's see, for the gears we have little herringbone gears. Supposedly this arrangement, this herringbone shape, helps reduce noise, but the fitment of the gears wasn't very precise, so I didn't really have any hope at it being quiet. Surprisingly, torque wasn't an issue on the motors as long as the accelerations were set to relatively sane values, which I discovered. Otherwise, I was skipping steps. But yeah, that's pretty much the basics of the mechanical design. It's got this stage that rotates on the bottom gear, and the motor here is static, and then it engages with that gear and rotates that one. Electrically, it was pretty simple. I didn't really have to do very much. I just plugged the motors into the respective ports, right there and there, and wired it up to the power supply, and it just worked. Alright, well, thank you, Joe. I really appreciated your class. It's definitely one of the most fun classes I've ever had, and I don't think I've ever had a class that I had fun in and learned something in. And this is definitely some stuff that will really help out my projects in the future, so I appreciate that. Thank you, Joe.